Hello, everyone. We are building a museum of computer technology in the age of AI. AI knows everything, yes, I know, but it also has everything the algorithms, the infrastructure. So, if one day AI writes down some code that threatens people, I hope at least one of you still understand it and pull the plug. In the last video, we talked about the theory of dynamic programming. Today, theory time is over. Let's crush a real DP problem, longest palindromic subsequence problem. Let's get our hands dirty and solve the problem from scratch. This is a classic longest palindromic subsequence. Also, we can find it in LeetCode. So, what's the mission? You are given a string, and you need to find the length of the longest possible palindromic. You can make by deleting 0 or more characters. Now pay attention to that word, subsequence, not substring. This is key. A substring has to be a continuous block of characters. A subsequence means we can pick and choose, just keeping the order. For example, if our string is BBBAB, we can grab the first B, second B, and the third B, and the last B. Then we got it. And its length is 4, and that's the answer. Step 1. How do we even approach this? Palindromes are all about symmetry. The first and the last characters have to match, and then the stuff in the middle also has to be a palindrome. We are dealing with the optimal solutions over an interval of the string, from some start I to some end J. That's why the problem is screaming interval DP. And step 2, define our state. What do we need to remember? This is the most important step. We'll create a two-dimensional array, our DP table, and dpij will store one simple thing, the length of the longest palindromic subsequence. We can find only within the slice of the string from index I to j. That's it. Step 3. Find the pattern, the state transition. This is where we become detectives. Think about our slice of the string from I to j. We only have two possibilities. For the characters at the ends, si and sj. Case 1, the characters match. These two characters can be the bookends of our palindrome. So we get to count both of them. That's +2 to our length. And what's left? The problem in the middle. Case 2, the characters don't match. Well, we can't use both of them at the ends of our palindrome. So we have to make a choice. We have to throw one away. Maybe we throw away the characters to the left, si, and see what's the best palindrome. It's in the range I+1 to j. The answer for that is di+1j. Or maybe we throw away the character on the right as j and see what's the best palindrome is in the range I to j minus 1. The answer for that is dpi to j minus 1. Since we want the longest possible palindrome, we will just take the maximum of those two choices. So if they don't match, see the formula. And step 4, what are our base cases? Where do we start? Think about the smallest possible string slice. It's a single character. So longest palindrome in a single character is a string, just the character itself. So for any I, dp I to I is always 1. That's our foundation. And step 5, the order of operations. This is super important for interval DP. Think about our formulas. To calculate dpi to j, we need the answers for smaller intervals like dp I+1 to j minus 1. This means we can't just fill our table from top to bottom, left to right. We have to calculate the answers for all the small intervals first. So we will iterate by the length of the substring. First, we calculate all answers for length 1, then all answers for length 2, then length 3, and so on, until we calculate the answer for the entire string. Look at how the table fills. Length 1, all is 1. Length 2, BB is 2, BA is 1. Length 3, BBA is 2, BAB is 3. We are just mechanically applying our rules, building on the results we already calculated. No guessing, no backtracing. The final answer just pops out the end. That's the beauty of this system. Now let's talk about the complexity. We have a matrix with roughly n squared cells, and for each cell we do a constant amount of work, so that's n squared time complexity. We also need to store that grid, so that's n squared space complexity. Could we optimize the space? Yes, you can get it down to On with a clever trick called a rolling array. But to be honest, in an interview, the On squared space solution is totally fine, it's clear and correct, and it shows you understand the core logic. And the big takeaway here, when you see a problem asking for the best solution on the range, your brain should light up and think interval DP. When you see a problem about strings where the ends matter, think what happens if I include both? Versus what happens if I have to discard one. This pattern will show up again and again. Let me leave you with this outlines of dynamic programming. DP is not magic, it's just organized thinking. It's a systematic way to break down a giant, terrifying problem into tiny, bite-sized pieces that you already know how to solve. You store those tiny solutions, so you never have to solve the same piece twice. and then you build your way up to the final answer. For DP to work, a problem needs two special properties. One is optimal substructure. This just means the best solution to the big problem is built from the best solutions to its smaller parts. And the second one is overlapping subproblems. This means you find yourself needing to solve the exactly same small problem over and over again. That's our cue to save the answer. You will see two main flavors of DP. Top down. This is the recursive way. You start with the big problem and break it down. And bottom up. This is the iterative way. Just like what we did. You start with the smallest pieces and build a pyramid. It's often faster and easier. And here's your secret weapon. Define the state, find the recurrence, find the base cases, figure out the order, get the final answer. And then comes the skill that only practice can buy, pattern recognition. After you have solved 50 deep dive problems, you will start to see the matrix. A new problem won't feel new anymore. You will say, oh, that's just another version of the knapsack problem. Here's my study advice. Don't just blaze through 100 problems to say you did it. Solve 5 problems deeply. Trace them by hand on a whiteboard. Draw the tables. Argue with yourself about why each transition works. Then come back a week later and solve it again from scratch. You are building intuition, not just a collection of solutions. My final thought is this. DP isn't about memorizing code, it's about upgrading your thinking process. When you face a complex new challenge, you won't panic. You will start asking the right questions. You will identify the pattern. You will apply the framework. You will test it with small examples. That understanding is your superpower. Protect it, grow it, and share it. Now go build something amazing. Okay, see you next time.